Hey everyone, welcome to this video where we'll be diving into what has been historically one of the most confusing and messy part of backend development, that is API versioning. Spring Boot 4, which is powered by new Spring Framework 7 features, has completely redefined it, giving us first-class API versioning support. This isn't just a hack now, it's a core feature. We are going to walk through the old, messy way of doing API versioning, then we'll upgrade each one step by step using Spring Boot 4 new versioning system. Before we dive in, let's quickly look at what makes this first-class versioning. Spring Framework 7 introduces API versioning through the new version attribute in the request mapping and all related annotations like get mapping, post mapping, and so on. This works in combination with API versioning configurer, which gives you complete control over how that versioning is resolved from the incoming request. So let's talk about configuration options. You have two primary approaches to configure how Spring resolves these versions. So the first one is property configuration. Using application.properties or YAML, this is the fastest way for simple strategies like headers or query parameters. Second one being Java configuration. Using web MVC configure interface, this is needed for advanced steps like path-based versioning or custom resolvers. We'll be using both of these throughout this video, so you know exactly when to use each one. Don't worry, this will not be just a theory class. I'll code everything live. Okay, before we begin, let's go to pom.xml. And here you can see we have the version as 4.0 and the Java version that we are using is 17. Before we even touch a controller, let's set up two simple model classes. This is important because for each version, we would have different response objects. First up, let's create v1 response object. This will be inside Pojo package. And let's name this as user v1. This will be of record type and this will be having string name. And then let's create v2 where we have realized a single name isn't enough. We need to break it into first name and last name. This is a classic example of API evolution. Perfect. Now we have two simple records ready to be served. Let's move on to the versioning strategies. So first of all, let's start with the classic old school query parameter versioning. This is when you have question mark v is equal to 2 or version is equal to 1 in the URL. It's often the easiest for browser, but again, the old way is too messy. First, let's create a controller that will be having the old way of versioning. So this will be inside controller package and let's name this as user old versioning controller. We'll annotate this with @rest controller. And this will be having request mapping. Let's define the base URL as API old users. Let's create our first endpoint. So this will be get mapping. Here, in order to include query parameters, we'll be defining params is equal to version 1. Let's write down public user v will be its return type, get user v1. Let's create another version of the same API. This will also be get mapping. We'll define params is equal to version v2. Let's accept this. We'll update this to v2. And this will be returning user v2. We are using the query parameter inside get mapping. We are essentially saying if the incoming request contains a query parameters with version 1, then execute the first method, and with the version 2, then execute the other method. This works, but imagine you have to create another version for all the endpoints. Then this would be so clutter to have versioning logic in all our mapping annotation. We can do better. Let's try it out. Now, let's create another controller as user new versioning controller. Again, this will be having REST controller and request mapping, and the base URL will be API new user. Again, we'll be creating two endpoints, both for different versions. So let's create first one at the rate get mapping. And here you can see we are defining a new attribute as version is equal to 1. Let's create its method, public user v1 get user v1. Okay. Similarly, we'll create the other version also for this API, get mapping, and we'll be defining version is equal to 2. So now our second API is also ready. Before we go further, let's click on this version. And now you can see this version is a newer attribute, same as what we have for headers and params. So now you can see this is much cleaner. We have a dedicated readable version attribute, no more messy conditional logic inside annotation. This is separation of concern done right. Let's try running the application. And yes, now you can see we have got some errors. Let's understand what we have got in this error. API version specified, but no API version strategy configured. We have used the version attribute in the get mapping, but we have not told how this version should be resolved. So let's define what and where of the versioning into the property file. We'll define a property as Spring MVC API version dot use query parameter, and we'll be defining the parameter name as version. Let's start our application. Okay, so now you can see we have not got any errors. Let's write down localhost colon 8080 API old URL, and let's add the param as version. We'll be adding 1. And now you can see we have got the first object. Let's update it to version 2. And this also works. So now we have first name and last name. We'll just change this old to new. Let's hit send. So now you can see we have got the response for version 2. And if I change this to version 1, and here we are getting the response for version 1. So if you go back to this new controller, we can see we have not defined any query parameters over here. Everything is handled by Spring out of the box by the property that we have mentioned in our application properties. Now let's move to another form of versioning, that is header-based versioning. This is how almost everyone had to do it in Spring Boot 2 or 3. It works, but watch how clunky the code gets. So let's go to our old controller, and here instead of the params, we'll be writing down headers, and let's change this to X API version is equal to 1, and we'll copy this, paste it to the second API also, and we'll update the version number to 2. You must have noticed in previous versions of Spring, any changes in the version logic, you have to do changes in your code as well. In the new Spring Boot 4, we do not have to make any changes in a new API, as the version configuration are in the property. And here, instead of the query parameters, we'll write down headers, and we'll be writing down the key name of the header. Okay, let's restart our application. So let's first test the new API. Instead of the params, let's write down the headers as X API version and put the value as 1. It works, and it works for the second one also. So now if we move to the old API, this will be also working the same way as the first one. Now let's move to the third way of versioning, that is the path-based versioning. This was arguably the most common hack for versioning. You just embed the version right inside the path, like v1 user. It's very clear, but it forces you to duplicate the path on every controller. So now let's go to old versioning system. And here in the request parameters, we'll remove this user and let's remove this headers and we'll be updating the API URLs to v1 user. We'll do the same for the second API as well. We'll be removing the headers and let's write down v2 user. Let's add the slashes at the beginning. This is the most common way of using the versioning in your APIs. So in the API, we'll just add v1 and you can see it works. This also works with v2 also. The Spring Boot 4 path versioning is probably the biggest change because we can use configuration class to apply the path prefix magically to all our controllers. This is where we use second configuration approach, that is the Java configs. We'll implement WebMVC configurer and override two methods. It looks like a lot, but it's powerful one-time setup. So in the application properties, we'll comment out the versioning that we have mentioned. Now, let's create a new class. And this will be inside config package. Let's name this as WebMVC configuration. Let's annotate this with @configuration. And this will implement WebMVC configurer. So if we go inside this WebMVC configurer, you can see we have different methods, but we are interested into this configure API versioning method. So let's copy its definition. We'll paste it over here. Let's add public and we'll override this. So we'll use configurer dot use path segment. So this is to tell Spring that we are using path segment for versioning purpose. And here you have to mention the index number. So if you see the API URL over here, we have API new user. If we mention 0, the version would be at the beginning. And then if we mention 1, it will be after API and so on. So for simplicity purpose, I'm using 0. Let's add supported version. So we are supporting 1 and 2. And let's add the default version as 1. Let's go inside WebMVC configure. We are also interested in this configure path match. Let's copy this signature, paste it over here, add public, and override this. So with this, we'll be adding path prefix and telling this prefix applies to what all places. Configure.add path prefix. So we'll be defining as v and the version into this curly braces. So the version that you'll be defining in the APIs will be placed at this placeholder. Okay, so now let's define to what all places this version should be added. So we have to add a predicate over here. Let's add handle type predicate dot for annotation, and this will be applied to everywhere we are using REST controller dot class. So with this configuration, any of our clean version annotated endpoints will automatically have v1, v2 path prefix applied based on the version they request. And here you can see we have not updated our API path in the REST mapping, but still our URL works. Finally, we have media type versioning, often called content negotiation. This is where things get truly messy in the old world. You use the accept headers with the custom MIME type. So to implement this, let's go to the old versioning controller. We'll just add the users in the request mapping and we'll remove the path from the get mapping. So the get mapping, let's add produces is equal to. So we'll be adding application VND v1 JSON for the first one. And for the second one, again we'll be adding produces, and here this will be using the v2 JSON. So let's go to the new versioning controller. Here again, you don't have to do any changes. The changes would be done in the configuration class. So let's go to WebMVC configuration. And here in the configuration API versioning, instead of using the use path segment, we can use media type parameters. Let's go inside this method. It accepts the compatible media type and the parameter name. This is quite easy to implement, but I'll give you a better way of doing it. So instead of this, we'll be using use version resolver, and we'll be creating a custom class for version resolving. Custom media type version resolver. Okay. Let's create a new class. This will be inside config. Let's implement the methods. First of all, we want the media type that we want. Let's go to the old versioning controller and we'll copy this MIME type. Let's add a comment and paste it over here. Now let's define the pattern, private, static, final. And let's write on pattern. Okay, version pattern, we have got this from Copilot. Move this to another line. So in place of D plus, we can write down any version over here. 1, 2, 3, any. Okay, so this is the pattern. So let's go to this resolve version method. And here from the request, let's get all the headers and with the key as accept. .var, let's name this as headers. Now, once we have got the headers, we'll be iterating through all the headers. Headers dot has more elements. And let's get the next header. .var, let's name this as header. So now we'll be iterating through all the media types and check whether there is a match with the pattern that we have. So let's parse the media type that we have got. Media type dot parse media types, parse the header, media type dot get type, and there will be a slash, and we'll be having the subtype. So now we have got the type of the media, and now once we have the type of the media, we'll be matching with the pattern. So version pattern dot matcher, and then if there's a match, we'll return the exact version name. And this version number would be used by Spring to identify the correct method. Let's go to web configuration, and you have this configure path match. We can comment this out. This is not required now. Now let's run this. Okay, so our application has started. Let's go to Postman. I have already added the headers for accept. Let's update this to v2. And this works. And similarly for old, this also works. And that's how you do API versioning in Spring Boot 4. We have covered the old way versus the new way. All four major strategies: header, query parameter, path, and media type. And we saw how to use both property configuration and Java configuration for version resolution. So the key takeaway is that Spring Boot 4 gives you first-class versioning support that uses clean, consistent version attribute in your controller, regardless of how client passes the version, making your code base dramatically cleaner. If you learned something new today and you are ready to clean up your APIs, please drop a like and a subscribe. Thanks for watching, and I'll see you in the next one.